Hello everybody. Good afternoon, and thank you very much for introduction. And indeed, it's a so nice place here, and I'm very great to present and talk about both. So I'm Elizaveta, and I'm from both, and I work as a senior data scientist there with focus on fraud domain, meaning that I'm mostly involved in building machine learning models which predict who are fraudsters, who are not, in all of our business lines. And also, I'm working on different kind of anomaly detection projects. I've been with both for more than 5 years already, and it means that data science team at both exists for slightly more than 5 years. So I've been there almost from the start, and I've seen how our team developed, how we've grew throughout these years, and experienced so many different projects which we've built so far. That's why today I will tell you about our data science team, and I will share with you how we structured, how we do our work. And second part of my presentation, I will share with you some different projects which we've built, and also I will touch a bit on this very hot topic of large language models. So now let's start with this question. What does data scientists do at both? Data science right now, it's quite a vague term because many companies use it differently, and so do we. In some companies, data science is closer to data analytics, but at both it's actually closer to engineering. And in other companies, you can see like such names of like SML engineer or ML scientist. And now a question for you. How do you think what data scientist and software engineer both produce? Any ideas? Is there anything they produce? Again, data scientists and software engineers. No? Okay, they both produce code. At both, software engineers, they live in TypeScript world, and they have their own packaging libraries, they have their own CI/CD systems, but their final product is backend services. And these backend services, they should be monitored, the code should be reliable, and also there should be alerting in place. As a data scientist, we live in a Python world and we use libraries from that universe. Similar to engineering, we have our own CI/CD systems, and we also care about code quality. We have different monitoring and alerting systems. But instead of backend services, we produce model endpoints. Another difference between data science and engineering and both is that when engineers work on their tasks, they more or less know what needs to be built. But as a data scientist, we more or less know what the problem is. So we step in early in product development process when something hurt or there is some business opportunity to improve. Now let's look closer what this final product of us as a data scientist is. And the first, I already mentioned, these are models. So we build machine learning models, and then we deploy them on live endpoints, which are consumed by backend. When I'm talking about one model, for example, I'm from fraud domain, Rider fraud predictor model which predicts fraud. In reality, there are several model artifacts behind it because in both we may have city-based models or country-based models, and both operates in more than 400 cities. So there is you think one model, but actually there are hundreds model artifacts behind it. And obviously, it would not be possible to do all this locally. So you would not deploy all these hundreds of models from just this laptop. That's why we've built our own internal ML platform, which simplifies and facilitates all this process, allowing to deploy all these hundreds of models simultaneously. And why we also build this machine learning platform internally, because there is no any other person at our company who will deploy models for us. So it's data scientists who are responsible for building models and then deploying them into production. But when model once trained, it needs to be retrained periodically. And also we build the model training pipelines. Actually, it's also done with our ML platform because we want to retrain model use fresh data, and it makes them more accurate. Not all models, they need to serve live requests. There are some models which just produce batch predictions, and they are stored in ETL manners. Example of that is our LTV model, lifetime value prediction model. So when we calculate LTV for our users, we store it in ETL tables, and we do it like daily or weekly, so we don't need to do it for every live request. What else we do as a data scientist? Yeah, we do some research. We are like scientists, of course. Sometimes we need to do proof of concept for our blog posts, for some blog posts, for papers, or for our own ideas, because we need to validate something, maybe some crazy things which we think may work or may not. And it means that some code goes to trash, but some actually turns into product feature. So not everything we do, go live to production. But this actually research stage is very important because it allows us to understand what's actually feasible and what is not, and it's great input for product planning process. And last but not least, so we not only working with machine learning models, but also with experimentation, everything around experimentation. So we help a product team with a more complex business impact estimation. So product manager and the analysts, it's good when they can do A/B tests, and then they can do it themselves. It's not a problem. But sometimes A/B test, or it's not feasible, or it's too expensive, and then we help with a more complex A/B test setup. For example, we do interleaved or switchback A/B tests, or we help with causal inference or simulation. Our data science team have more than 40 people right now, and we spread across 5 hubs in Europe. We have 2 offices in Estonia, in Tallinn, in Tartu, and also we have engineering hubs in Warsaw, in Berlin, and in Bucharest. But overall, I counted actually, it's yesterday, it's a very nice number. We have 100 ML pipelines. Because last time I presented a couple of weeks ago, it was 99, but it's already now 100. So nice number to put on slides, But by my pipeline, I mean business case solved. So for example, rider fraud predictors will be just one case. If you look at ratio of projects per data scientist, you see that it's not actually more than 1, but it's more than 2 projects per data scientist. And this ratio is somewhat special because there are companies where there are several teams working on just one model, but for us it's the opposite way. So there are more projects than people working. And I think it's I'm really glad to be in this position, and it's all due to our investment into internal machine learning platform, and this kind of resources which we put into building it really paid off through all years. So we've talked about our team. Now let's look at what kind of projects we have. I will not cover all these countries for you today, no worries. I will just give you some sneak peeks into projects where I can show some visuals. And kind of starting with where both apply machine learning everywhere. Like all of our 5 business lines have some kind of machine learning deployed there. And you can imagine if you do a write with both, you enter destination and go to the destination, at point when write is finished, there are more than 200 calls, model calls being done. So it's a great amount of cases covered with machine learning at both. Now let's look at projects. Okay. I don't have internet, probably, and I cannot show demo. Just let me quickly fix it.
Do you want me to add
I should be able.
Yeah, or the hey.
It doesn't work actually for me. Yeah, now it should be.
Okay.
I hope now it will work. And loading. Yeah, so basically I wanted to show you a demo of our driver license verification. So when our drivers sign up, they need to submit documents, and then we need to verify if this driver license or any other document is valid or not. And we have a machine learning model which extracts all this information and then check it. So why we've built it? Because before it was our people checking this, and it's a very boring work actually, because you would not want to just look at all these driver licenses the whole day. We wanted our people focus on more added value, and actually this object character recognition, OCR, it's a known problem, and we built this model, and it's not only remove manual work, but also it decrease the amount of mistakes done. So when people review this for a long time, mistakes occur, but with models, we actually notice that there are much more or less errors. What else is important here is that we improve document handling time. So now drivers need to wait less time for their documents being verified, and it's actually good, better experience for them right now. And I'm really glad that some documents process completely automatically right now, and it's really cool, without any human involved. Next projects which I want to share. So who of you seen this behavior on streets where you live? It's not even two, it's like a 3-person riding one scooter. And this poor man, like, passing by. This tandem riding, it's very dangerous. And it's not only dangerous for people who ride scooter, but also for people around, because they can accidentally be involved in that as well. That's why we've built a tandem detection model. So it runs fully on device. On a scooter, it uses data from accelerometer, engine current, voltage, wheel speed, and then it predicts is it a single or multiple people riding a scooter. Then when we detect tandem riding, we send the notifications because we want to push users for safer behavior. We want to make safer experience not only for people who use scooters, but also for people around, because we want to make cities as a safer place. Now let's look at another project. It's now for text domain. So if you use both, you enter a destination, and then you usually see this list of suggestions, kind of which propose to you when you can click and not type the whole address where you want to go. Before, we used Google APIs to create this list of suggestions, but as you see from this quick demo, sometimes it failed to give any results if there are too many mistakes, in address. Then we decided, okay, let's build our own autocorrection model. We did it, and we've noticed that it even has a better search quality. So as we use our own data to build this model, it was more related to our use case, and that's why it produced better results. And what is even more important, that we are now less dependent on other providers, and we save quite significant amount of money on that as well. So all the 3 cases I shared with you before, they are using unstructured data. But reality is that still, like, majority of cases where we use machine learning models, they use tabular data. Like in fraud domain, we kind of all of our projects using tabular data. I shared with you a couple of projects with computer vision and from text, but all these advances in large language models, they opened up for us more this area. And right now we are exploring where we could use transformers and could it bring for us additional value. And a quick example from this. So it's now from customer support automation. So when users write to us about their questions, issues, before starting to solving it, we need to classify what the type of issue this ticket is, because then we will redirect to specific engine who is dealing this type of issues, and it will decrease the resolution time for ticket. Before, we had a keyword-based search model, TF-IDF, if you know about it, and which classified these tickets. Results were quite good, but then we started to experiment. Maybe we could use transformer-based models for issue ticket classification, because our assumption was that it should be more accurate for corner cases, smaller issues, and also for cases where there are several types of issues in the one case, which could not be identified with our previous model. It's still like experimentation which we are doing, but what we've noticed already is that this model with transformers for CS ticket classification, it actually shows much better overall accuracy, and top 1 accuracy and top 3 accuracy. So it's quite good. That we are kind of opening up this sphere, and we already finding some something which we can use. But like all these projects were kind of successful, but sometimes something goes wrong, and sometimes it's not all this data science work, like you just push your data and receive the good results. Sometimes you have challenges. And in the end, I would like to share with you this one example which we had this summer. It will be from fraud domain. I will not go into details of what these chargeback fulfillments are, just grasp the idea that we had a binary classification model and we wanted to transition to multi-class classification model. So now instead of 2 classes, we wanted model to predict 3 classes. We kind of, at both, we experiment everything, and here as well, we wanted to do A/B tests to see what kind of performance we would get from this change. So we planned the A/B test where 50% of requests went for our old model and 50% of requests went to new model. We started A/B test, but we planned it for 2 weeks, but it was shut down in 1.5 hours. This plot actually quite nicely illustrates what happened. Orange line was what we expected model, like on average prediction to give. But when we started A/B tests, this blue line kind of started increasing. And the thing is that we apply several actions based on model predictions. So it started to affect good users, and that's why we were required to stop A/B test. We were quite frustrated with that because before starting A/B test, we did extensive validation on historical data. We did silent live, where model was actually live but not affecting users. And from that plot, you can see that expected and observed values during silent live, they were quite similar. But during A/B tests on that plot, you see that like how huge the difference was, and it's only for 1.5 hours. Of course, yeah, then we started to investigate, and we spent 2 weeks checking different hypotheses. Maybe something was wrong with model threshold selection or score transformation. Then we also checked most important features. Maybe there were some updates done for these features, but we found nothing. And only then, when we started to dig in like less important features, we found 2 features where we saw changed feature distribution. So before we started A/B test, and after we before and after, there were like changes in the distribution value of that features. We started to talk to our backend team who are responsible for them, and they told, okay, on a day before A/B test, they did their refactoring for this feature. They didn't tell to us because for them it's just refactoring, like nothing should break for sure. But we found that we asked them to investigate more, and we found that there was a bug in that refactoring, and it caused like this distribution of feature to change, and it affected model predictions in live. And we were unlucky that it was done right before our A/B test. We haven't noticed during silent live because there was a day between our silent live and A/B test, and what happened right on that day. But anyway, in the end, we found root cause. Everything was fixed, but it just shows how like data quality matters, and you should always be confident in what data you use. And to conclude, I wanted to leave you with exactly that message, that machine learning models are only as good as the data they are trained on. And as both, we care about data quality, and we really take it seriously, because we understand it's actually what directly influences will project you be successful or not. Thank you.